Yeah. These are rough ones. Actually, the first one's not that bad. If you see it. I don't know. Let's just jump into it. We want to solve sine of x minus cosine of x is equal to 1 on the interval from 0 to 2 pi. Alright. Put up in the corner exact values only. When we're doing this, we got to get exacts. Well, I'll say it again. So that means don't ever give me a decimal. Don't give me a decimal unless that decimal is 0.5. You know, for a half. Don't give me a decimal. Alright. So there's a simple way through this problem, and there's a really tough way through this problem. We're going to start off with the tough way. We look at this, and can we change sign? No. You can only change sine squares. Oh, what about cosine? No. You can only change the squares. We have those Pythagorean identities that allow us to change squares. We don't have any squares. And the issue we have in this moment is, dude, we got like an x minus a y is equal to 1. There's two different variables. How the hell are you supposed to solve? It's two different things. I'm going to tell you, like, yeah, go find x. 1 plus y? You're like, no, I want numbers. You can't find it. So we need to be able to change it. And the only way we're going to be able to mess around with this thing algebraically would be to square both sides. But when you square both sides, that is danger, danger, and danger. Huge danger. Here we go. You know what I mean? Square both sides of this thing. Now I'm just going to start with the danger of doing this. Over here on the right-hand side. That 1 squared. That's 1, right? That's no big deal. But that could have been a negative 1 as well. Wouldn't you have gotten the same answer out? Negative 1 squared is also 1. The math doesn't understand. It's going to give you answers for both negative 1 and positive 1. Because of what we've just done. You're going to have to check all of your solutions. I call them phantom answers. Your text will call them extraneous solutions. It's these answers that pop up, and if you don't check and you don't plug them back in, you're going to get the wrong ones. It's all going to have to do with this sign error that occurs right here, that if it would have been negative 1, we would have got the same thing. So, all right, enough of that. So we have sine of x minus cosine of x, all squared, which means do not just square the frickin' components. It's called FOILing, first, outer, inner, last, right? So you're ending up with a sine squared. That's sine times sine. And then sine times cosine times sine times cosine. They're both negative. You get negative 2 sine x cosine x plus cosine squared of x is equal to 1. Cool. Cool. Now what we're always looking for, what we always want to find is we want to find positive cosine squares and we want to find positive sine squares in the same line, because you know what sine squared plus cosine squared equals? Yeah, buddy, it equals 1. So we change that into a 1, and we write 1 minus 2 sine x times cosine of x is equal to 1. And shoot, there's 1s on both sides. Let's just subtract that stuff out. Wow, we're just flying through, and here we are. 1 minus 1, that went away, that becomes a 0. Oh, sweet, we made it. We're here. We're done. It's the zero product principle. We have negative 2 times sine of x times cosine of x. So let's just go. We got 3 things being multiplied together. We go negative 2 equals 0. Oh, well, that's freaking stupid. Ignore it. We could have just divide out the negative 2. Right? 0 divided by negative 2 goes away. Ignore the frickin' negative 2. Negative 2 doesn't equal 0. So we can ignore it. Now we just move to the next, the sine of x, set that equal to 0, and cosine of x. We set that equal to 0. Don't trip about that freaking number. Don't write down x equals 2. I see that shit. Don't do that. Alright. So sine of x equals 0. I'm going to assume you understand that this is at 0 and pi. Those are the two places in between 0 and 2 pi, such that sine of x is equal to 0. And then x is equal to, with cosine of x equals 0, with odd multiples of pi over 2. So pi over 2 and 3 pi over 2. There would be our 4 answers. We're super stoked. We're like, yay, we got answers. Problem is, only 2 of those are correct. You have to take them and plug them back into your original equation. So from up top, you got to go plug it in. Now, you don't want to do what I just did. Because there's going to be a moral to the story. When we start to plug everything in, I want you to pay attention to the pattern. This is going to help you to solve your problem in the homework. Pay attention to the pattern on the right when we start to plug things in. So we're going to put in x equals 0, because that was one of the answers, and x equals pi over 2. We're going to look at x is equal to pi, and we're going to look at x is equal to 3 pi over 2. That was the 4 answers we got, those quadrantial angles. The quadrantial angles, the ones that are in no quadrant. And we're going to plug them into our original little equations. We're going to say sine of minus cosine of is equal to. We're just going to see what the answers are, right? Because that's what our question said. We want it to equal 1. And you can do this in your head. I'm just showing you these. I'm sure. So we're just going to take 0 and plug it in and see what happens. Right? Just checking our answers. Just checking. So we're like sine of 0 is 0. Minus cosine of 0 is 1. That equals -1. Oh, shoot. That can't be the answer. -1 does not equal 1. So we're like, yeah, you can kick rocks, dude. Get out of here. All right, let's plug in pi over 2. Let's see what happens. So you get sine of pi over 2 minus cosine of pi over 2. Sine of pi over 2 is equal to 1. Cosine of any odd multiple of pi over 2 is always equal to 0. 1 minus 0 is 1. Oh, shoot. Yeah, there it is. We found one. Pi over 2 works. Now we can take this pi and we can plug it in, see what that's going to turn into. And we're like, well, sine of pi is 0. Cosine of pi is -1. 0 minus what? Minus -1. That's +1. Well, shoot, we found it. Now this last one isn't going to work. I already told you it wasn't. But let's check it out nonetheless. We get 3 pi over 2 plugged into both of these. Sine of 3 pi over 2 is going to be -1. Minus cosine of any odd multiple of pi over 2 is always equal to 0. So we get -1, and that cannot be the answer. So we have to go plug it in at the beginning. But really, where do sine and cosine equal 1? If you're talking about sine and cosine, the only way that happens is when one of them equals 0. Notice, there's always a 0 somewhere. And then the other one's going to be 1 or -1. It's just a game, making sure you get that shit memorized up. Maybe when you mix it with a sine and a tangent or something, you realize the tangent only happens, it has 1s at pi over 4s. So that would work. Maybe you need to look at where 0s might be. Moving into this next one. Okay. This is a beast. This is a huge pain in the ass. In full honesty, I've done this before. I posted it. Found out there was a mistake because a student let me know. I screwed this one up the first time. So hopefully this time I can go through and do it. I'll actually double check my work. So this is a tough one. But again, we're going to want to get an exact answer on this. This is, for us, this is level 10 out of 10. This is as rough as it gets. This is rough, though. I mean, if you fully understand what's going on through this problem, I'm bowing to you and I'm saying, good job. You're going to do terrific in the things that you need to move forward with in just the math part. All right, I need to start working or I'm going to make this video way too freaking long. So we look at this and we want to find ourselves an exact answer. This seems to be in the form of maybe like a 6y squared plus y minus 1. If we were to say, let's let y equal sine of x, just so we can see what's going on. You know what I mean? Because that's a lot to look at. That's a lot to factor, especially with a leading coefficient on it. So I'm going to do the stupid little trick that you can do or not do. Take it or leave it. It just is what it is. When I have a leading coefficient, I don't like those things. They suck. I wish that was gone. So I bring it over to the other side, and you get y squared plus y. And then we get 6 times -1. That's -6. That's -6. So now we just go through and factor as normal. So we're like, we need 2 numbers multiplied together that equal -6, but they sum to be +1. Pretty sure that's +3 and -2. Cool, so it's now factored. Well, let's bring that 6 in. Once you have a factor, bring whatever that leading coefficient was, and you bring it down and makes it the denominator of both. The denominator for both, and we want to reduce those fractions. So that's a half. That makes a third, and whatever's left over, we just bring it up. We just bring it. This is your diamond method. It's whatever that is. I refuse to learn that diamond method. I don't know. I stay away from it. I use this silly, stupid method. But it works, and there's no guessing check, at least. Not as much. But, again, take it or leave it. You factor however the heck you factor. So we got it all factored up. Now, in the meantime, again, this is not equal. In the meantime, this is a trick. It's a trick. It's not equal. Don't put freaking equal signs in this. The only thing that's equal is this to this. Okay? Those two are equal. So we go back in and we're like, well, wait a second. Isn't this 2 times y was sine of x? And y was sine of x. Oh, dope. So we can just actually bring this up top. And now let's start looking at this problem. We will move this right here. We get 2 sines of x plus 1. It's 3 sines of x minus 1. And we set it equal to 0. Zoom in and let's get it. We have the zero product principle working here. We got a factor. That's what we wanted. So now we can take our 2 sine of x plus 1 and set that equal to 0. We can also take our 3 sine of x minus 1 and set that equal to 0. As I go through and solve, I'm not going to show my algebra through this, but this is going to be sine of x is equal to a half. And over here we're going to have this, or negative a half, I misspoke. Sine of x is going to be equal to a positive 1/3. Now the trick to this problem, dude, it's got the exact answers, and we don't have some sort of base knowledge for a 1/3. I don't know that answer, and I'm asking you for an exact value. So this is what really makes this problem freaking messed up, okay? Let me get rid of some of the noise over here so we can go through and see the craziness that's about to ensue. So for down here, I'm just going to write down the answers for sine of x equaling negative 1/2, 2 values in between 0 and 2 pi. The reference angle is pi over 6. We must be in the third quadrant. Hence, we have 7 pi over 6 or 11 pi over 6. There's 2 answers. It's getting this other one. Now, how this is going to start is we don't know anything about it. If you write down anything from a calculator, wrong. It's just freaking wrong. We want an exact value on this sucker. Exact. So this is how we're going to do it. We're going to want to get that angle out of the argument, because that's what we're solving for. These x values are angles, those radians, right? So let's hit it with an inverse, because we don't know. So both sides of this thing, we're like sine inverse, sine inverse. And what that does, remember that sine inverse of sine is just equal to the input if? Well, dude, it's equal to the frickin' input. It's x is equal to sine inverse of 1/3. That's a reference angle, dude. That's a frickin' reference angle. Sine inverse, isn't that a positive input? That's a positive input. So what that just did was put us over in the first quadrant saying our reference angle is equal to that sine inverse of blah, 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 blah. Yeah, sine inverse of 1/3. But we need to find 2 frickin' angles. Not one. We got one. Here's one of your frickin' answers. Boom. Inverses are angles. That's what we're looking for. These x's are frickin' angles. But we need to go find the other one that's over here, where sine's also positive, that has the same reference angle. We need to know, what is this? What angle is that? That angle is pi minus the frickin' reference angle. Hence, our answer, our last answer, is going to be pi minus our frickin' reference angle. And there it is. I told you. It's a beast, huh? It's a beast. So we have to get those 2 angles, right? There's always going to be 2 spots when we talk about sine and cosine. From 0 to 2 pi, we're going to get those 2 answers, unless we're at 1 or negative 1. So we needed to get both of them. I know that's a rough one, but if you follow along with this, if you can make heads or tails of what's happening in here, shit, you're off and running. So, thanks for hanging out.